In this video, I'm going to go in depth into a critical step of forging a katana, the forging of the sunobe. If this step isn't done properly, your resulting blade will be clunky and misshapen and will require a lot of profiling to fix. In a worst-case scenario, a poorly made sunobe may prevent you from ever producing a blade with the shape you're looking for. On the other hand, a perfect sunobe forges out easily into a blade that requires barely any profiling. If you'd like to attempt to forge a katana, I can't emphasize enough how important it is that your sunobe be as perfect as you can make it. In my experience, forging the sunobe requires quite a bit more time and effort than forging out the bevels on the blade. Alright, let's start at the beginning and work our way through this. Why do we need a sunobe? Well, if you take a simple rectangular bar and hammer edge bevels into it, you don't get a katana. What you get is something more like a scimitar, a blade that grows wider toward the point. In order for your sword to get thinner and narrower toward the point, you have to forge it from a bar that gets thinner and narrower at one end, and that's the sunobe. A sunobe can be thought of as having two segments, one that corresponds to the blade of the katana and one that corresponds to the tang. We're going to ignore the point for now. Each of the two segments tapers perfectly evenly in both width and thickness from the widest point to the narrowest, and this presents a challenge for the bladesmith. How in the world do you take a rectangular bar and shape it into a delicately and perfectly tapering bar using a hammer, without accidentally introducing thin spots or thick spots, or without making it taper too much or not enough over a certain length? How do you make it geometrically perfect? When I first began studying Japanese sword making years ago, the person who I learned from, who is an amazing bladesmith and makes beautiful katanas, basically just said, "Keep calipers handy and measure as you go." I didn't find this advice terribly useful. The calipers tell you how wide and thick your sunobe is at any given spot, but they can't tell you how wide and thick it should be at that spot. How do you know how wide and thick the sunobe should be at any given point? I've experimented with several methods over the years, and the one I'm going to show you here is the one that produces essentially perfect results for me every single time. I'll warn you that I'm a little OCD, and this method uses both geometry and algebra. Okay, let's say that I'm starting with a piece of bar stock that's 10 millimeters by 26 millimeters by 610 millimeters. Even though I'm American, I use millimeters rather than inches and fractions of an inch, because the math is much easier in metric. I start by mentally dividing it into two segments, one that will become the blade of the sword and one that will become the tang. I need about 100 millimeters for the tang, and this leaves 510 millimeters for the part that will become the blade. For simplicity, for most of this discussion, we're going to ignore the tang part and just focus on the blade part. So the blade part is 10 millimeters by 26 millimeters by 510 millimeters. One thing that's important to know is that the volume is constant. No matter how I stretch it or deform it, the volume will always be the same. I can use this knowledge to calculate the length of the sunobe. Let's say that I want the point end of the sunobe to be 7.5 millimeters by 21 millimeters. I know that the sunobe will look like this, with one end, the original 10 mm by 26 mm dimensions, and the other end 7.5 mm by 21 mm. It's going to be more stretched out than the original bar because as you taper it, it's going to elongate. But by how much? Understanding that the volume must be the same as the original rectangular bar, I can use this formula to calculate the new length. So now I know that if I somehow made a geometrically perfect sunobe of these dimensions from this piece of bar, this would be its length. Next, I mentally divide the bar into 5 equal segments, one for each millimeter of taper in width and half a millimeter of taper in thickness. Now, if I just knew what lengths of my original rectangular bar would hammer out into each of these segments, I could mark those lengths on my bar and start forging. Well, that's something I can calculate. I know all the dimensions of each of the 5 segments, and I can use that information to calculate the volume of each segment. And knowing the volume, I can easily calculate the length of my original bar that corresponds to each segment. So I mark my rectangular bar and I hammer out each segment. Then I carefully blend the segments together, making them into one continuously tapering bar. And the hard part's over. For the tang, I generally just eyeball it. It's only about 4 inches long to start with and forges out to about 6 inches, so getting it to taper evenly isn't that hard. Besides, there's a fair amount of variation in the shapes and lengths of historical Japanese katana tangs, so the exact dimensions of the tang aren't critical. For the point end of the sunobe, I hot cut diagonally across the bar, then forge the point over into the center, and that's it. The sunobe is done. Now this may seem to you like a ton of geometry and algebra, but I strongly feel that it's worth it to do the math, because half an hour or so of number crunching ends up saving me hours and hours of work later. and maybe even saves me from wasting weeks or months of work on a project that will never turn out right. As I said earlier, this method enables me to produce an essentially geometrically perfect sunobe every single time, and that perfect sunobe forges out relatively easily into a perfectly shaped blade. One thing that makes this whole process much easier for me is this spreadsheet that my beautiful and brilliant wife made for me. All I have to do is enter the dimensions of the rectangular bar I'm starting with, and it instantly spits out all the other numbers. So it takes me 30 seconds instead of 30 minutes to find the measurements and get started. Now one final comment and I'll end this video. I mark the segments on my rectangular bar by cutting little notches into it with a cutoff blade on an angle grinder. If you watch my second video in this series, you can see the notches. You may think that this would damage the final blade in some fashion, but it doesn't. As I forge out the sunobe, these notches begin opening up and flattening out. You can see that here. And if, as I forge the bevels on the final blade, I position the notches so that they're on the cutting edge rather than the spine edge, they continue to open up and flatten out until they disappear, and I usually can't even see them after the rough forging. But if I can, their remnants are completely and easily erased during the profiling. And so there you go, all about sunobes. If you like this video, please give it a like, and don't forget to subscribe to this channel so you don't miss out on new videos as I create this handmade katana.